our motion under gravity free fall. And with this simple diagram, you don't even need any thought, any much illustration. This simple diagram explains everything under this motion under gravity fall. So let's check what is happening in this diagram. Okay, this diagram indicates, let me say, when a stone is being thrown up, let me say if you get a stone and throw it up, this is the direction of your stone. As it is going up, it keeps losing its speed. Do you know why it is losing its speed? It is going against the force of gravity. When you throw something up, you know that the gravitational pull is downwards force. Do you get me? And if you throw anything up, the gravitational pull, it is against the force of gravity. And when anything is against that force of gravity, acceleration will be negative force of gravity because it is against it. As the stone keeps going up, it keeps losing its speed. It keeps losing its speed until this maximum point. When it comes to this maximum point, it has lost all its speed. And at this maximum point, the final velocity is 0. No speed again. And at this maximum point, it will start to decline, to fall back. As it keeps on, before it starts falling back, the initial velocity is 0. Then it starts falling back. And once it is falling down, it now starts to obey the force, the laws of gravity, or it starts to obey gravitational rule. Do you get? And this gravity turns to positive g. It keeps falling down, falling down, falling down. And as it is falling down, its speed is increasing until it attains its maximum speed once it hits the ground here. Once it hits the ground, it attains its maximum speed. This is where our velocity, that is our final velocity, is maximum. Maximum. At this place. Once it hits the ground. So this is it about motion under gravity fall. But every formula that we are going to use in solving this motion under gravity fall is gotten from our linear or uniform motion equation. And our linear equation says that, this is our linear equation, it says that V is equal to AT plus AT plus U. It says that V is equal to AT plus U. And again, and S is equal to UT plus half AT squared. And the final one is V squared is equal to U squared plus 2AS. From here, we are going to derive all the equation we are going to use for this one. This is for our linear equation. So when we are going to change these formulas to a formula that we are going to solve motion under gravity for, any place we see acceleration, we change it to what? To g. Any place we see h, s, we change it to height. Because now we are dealing with up and down. That is high, up and down. We need height. Do you get me? Any place we see distance, we change it with h. Although, okay, now look at this positive sign. Due to we don't know whether the object is going up or down when driving this formula, we will put our positive or negative sign. Once we put it, then while solving, you will choose the direction of the force or the direction of the ball. If it is going up, you personally will turn it to minus. If it is coming down, you will change this to positive. So let's change this into equation under gravity fall. Our V now will be this one from here. It will be V equal to our A. We change towards G. That is U. Let's start from U first. U plus or minus AT will be now GT. Do you get me? Plus or minus. We don't know whether this gravity is going up or down. So whichever one it is going, you choose your sign. If it is going up, it is minus. If it is coming down, it is positive. So this second one is now our S. Anytime we see S, which is distance, we change it to height. This now will be our height, which is equal to, this is UT. Yes, this is our UT, plus or minus half. Anytime we see A, we put what? G. This is our T squared. So the third one, which is V squared is equal to U squared plus or minus. This is 2. Anytime we see A, we put our G, which is this, which is G. Anytime we see S, we put H. And these three equations, this is 1, this is 2, this is 3. is what we are going to use to solve every calculation under motion under gravity 4. So let's quickly jump into calculations that we are going to use these three formulas as we used this one previously. Let's go and use these three and solve questions. Okay, right here is our number 1 example under equation under gravity free fall. And number 1 example says a cricket ball is thrown vertically upward in an initial velocity of 40 meters per second. Find a cricket ball is thrown upward with an initial velocity of this 40 meters per second. They say that we should find I, the velocity, after 3 seconds. Its velocity, I is the maximum height attained and the time taken to reach it, the maximum height and time in which it takes to reach the maximum height. Okay? The I is the total time taken for the ball to return to the ground. He throws the ball upwards. We want to know the total time taken for the ball to go up and come back to the ground, neglecting air resistance. So before we start, we don't know which formula to use out of the 3 formulas that we have just write. So let's write out the 3 formulas, and before we start each one, we check the formula to use. The first formula says that V is equal to U plus or minus GT. The second formula says that H is equal to UT plus or minus half GT squared. And the third formula says that it is V squared equal to U squared plus or minus 2GH. So this is the 3 formulas that we are going to use to solve every question under this topic. Okay? So let's start now. This is our solution. And let's divide our board. Okay, the first says that find its velocity after 3 seconds. So this is given I. Let me write I. Given for I. Given from the question, we have been given the initial velocity, which is 0, equal to 40 meters per second. Then from this I, its velocity after 3 seconds. Time, it has given us time, which is 3 seconds. 3 sec. Okay? Okay, let's now go and check from our equation which formula we are going to use. But again, remember that, let me just draw that diagram again. This is our diagram. This is equation. This is our equation. Here, when it is going up, A is minus G. When it's coming down, A is plus G. At this maximum, V is equal to 0. At here, U is equal to 0. This is our diagram. Okay, let's come over here now. We are looking for what? Velocity. Okay? We are looking for velocity. And V, you remember that V is equal to U plus or minus, from here, U plus or minus GT. We are looking for velocity. Our initial velocity is this, our time is this, our gravity is constant, which is 10 meters per second. Okay? So therefore, we are going to use this, our first equation. Why are we not using this? We don't know height. There is no height, and here there is height. But from the question, we are not given height. So let's simply go and substitute here and get our answer. This is V is equal to our U is 40. Our U is 40. But if we check, the ball is going up. How can we determine our sign, which sign to use? From this question, a cricket ball is thrown up. Once the ball is going up, it is going against the force of gravity. And once it is going up, our A is minus G. So our A is supposed to be minus, our G is 10 times, our time is 3 seconds. Okay? And finally, V is now equals to 10 times 3 is 30, 40 minus 30, this will give us 3 meters per second. And this is our number 1, which is the velocity after 3 seconds. So we are going to be solving everything here because we need this diagram to analyze every question before we start solving. We are done with our I, which the answer is 10 meters per second. Okay, let's go back to II, which says the maximum height attained and time taken to reach it. The maximum height. Okay, they want to know the maximum height at this point attained. But we know at the maximum height, our velocity is equal to 0. Our final velocity is equal to 0. Okay, from the question, from this first one, they gave us our initial velocity. U is equal to 40 meters per second. And now, at maximum height, they said that we should find the maximum height attained. And at our maximum height, V is equal to 0. Okay? Okay. Then, which formula are we going to use? You get, if we come here at this first formula, we have time. But is there any time given in this question? We are done with this question I. So, this thread doesn't go for this one. So, in this second I, is there any time given? No, therefore, we're not going to use this first formula. And T is also in this second formula. That means we're not going to use first and second formula because there is no time, and time is not given here, and they have time in their formula. So let's simply go ahead and use this final formula, which has no time. You get? And it says that V squared is equal to V squared plus or minus 2G H. And we are looking for our height, the maximum height. Our velocity, let's substitute. Our velocity is 0. Here is supposed to be 0, which is equal. Our U is 40 squared. 40 squared. Is the ball going up or down? They want to know the maximum height attained. So now we are looking for the maximum height. It is still going up. That's how we know the maximum height. Okay. And this is supposed to be minus. Once it is going up, it is going against force of gravity. So this here is minus 2 times 10 times our H. Okay, let's go over and make H subject of the formula. 40 squared, let's punch our calculator. 40 squared will give us 1.6. This is 0. Is equal to, give us 1.6 exponential 3 minus 2 times 10 will give us 20 times H. This is 20H. Making H subject of formula, we push H. Minus 20H will go over to the quantity sign, making this 20H is equal to 1.6 times 10 raised to the power 3. Making H our subject of formula, H now will be equal to this divided by 20. 1.6 exponential 3 all over 20. Our H now will be our answer divided by 20. That is, our answer is equal to this divided by 20 to give us 80 meters. This is our final answer for the maximum height. We have gotten our maximum height, but remember, they said maximum height attained and the time taken to reach it. So let's get the time taken to reach here now. From our formula now, we know our V, we know our U, and we have gotten our H. So we are going to, and we are looking for what? And we are looking for time. Let's go straight and use the first equation. It has time, and we have U, and we have V. You get? So this is the only equation we are going to use to get our time. Okay. From this first equation, it says that V. Okay, let me wipe this board now. Let me wipe here. It says that V is equal to U plus or minus GC. Our V here is, our V is 0. Then our U, where is our U? Initial velocity is 40. This is 0 is equal to 40 minus, it is going up. We want to know the time in which we get to our maximum height. Minus our G is 10 and our time is T. So from here, let's go ahead and solve. Making this subject of formula means that 10T is equal to 40 and our time T is equal to 40 over 10, which will give us 4 seconds. Okay? Then the next is our we are done with number 1 and number 2. Let's come over to here. And here says the total time taken for the ball to return to the ground. We now want to know the time taken to go up and come back to the ground. Do you get me? Okay. The time taken to go up. Let's go again and find the time, the total time taken for the ball to return to the ground. neglecting air resistance. But if we check from this our solving, or if we go ahead and solve again, we are going to use the same formula, because from what we are given, this is the only formula we can use to get our time. We will repeat this solving automatically. Do you get? Or if you want, if you're in examination hall, you just go ahead and repeat it for them. Our final velocity is 0, which is equal to u. U is 40. 40 plus or minus g, 40 minus, this is 40 minus 10t, and t now will be equal to 4 seconds. This is the time. From this question, let me redraw this. This is our maximum point. This is where velocity is 0, and this is where this is 0. A is equal to minus g, where A is equal to plus g. Okay. Anytime it takes this object to rise from here to this point, will be the same time it will take it to fall from here to here. Do you get? This is equal. Let's divide this into 2. Anything that is happening here is also happening here. If it takes a ball 1 hour to rise from here to here, it will also take that ball 1 hour to fall from here to here. I just draw this thing. Let me use from here and show you how to get the total time. Once you have gotten the time it takes to come from here to the maximum point, just square the time, just times the time by 2. Do you get? Because total time now, our total time is equal to 2 small t, which is 2 times 4 will give us 2 times 4 will give us 8 seconds. And this is our final answer. This is the total time it will take us to return to the ground when you throw a ball up. Anytime it takes to reach this maximum height will be the same time it will take to hit the ground. And here is where we have our maximum velocity, our Vmax. This is all about it in this question. So let's kindly go over to second question. Over here is our second example. It says that a ball is released from a height. A ball is released from a height above the ground. Find its velocity after 5 seconds. Okay? So let's go ahead and write our solution. Our given data. Number first is time. Time is equal to 5 seconds. The ball is raised from a height above the ground. Find its velocity after 5 seconds. And our g is 10 meters. Acceleration due to gravity is 10 meters per second. So let's check which formula will suit this our data first. And let's analyze this question. When you are having a ball in your hand and you release it on the ground, that time you are having the ball on the ground, the velocity, the initial velocity is 0. Okay? So let's go over here and tell them that our initial velocity is 0. You are having a ball and you release it. Initial velocity is 0. Okay. And they say that you should find its velocity after 5 seconds. So we are now looking for V. So we have T, G, U, and V. Let's go to our question. Here we have V, U, 2, G, and H. We don't have H here. That means we can't use this. This one we have H here. That means we can't use this. There is no H for us to solve it. But here, this is our right formula to use. We have V, we have U, we have G, and we have G and T. So let's simply go ahead and substitute our formula. This is V equal to U plus or minus G, GT. The ball is falling down. So our G will be positive. It is falling down. If the ball is going up, our G will be minus, negative. So that our velocity is equal to U, which is our initial velocity, is 0. The ball is held at hand, 0. Plus our G is 10 times our T, which is 5 seconds. Our T is 5. So our final velocity is equal to, this is 10 meters per second times T. This is 50 meters per second. This is 10 meters per second. Our acceleration times second, 5 seconds, it will give us 50 meters per second. And this is our final answer. Okay. this is where we leave it in motion. Believe me, we have 50. We have in our exercise package, we have 50 to 100 questions in this motion. Believe me, if you can go through those exercises, there's no question under motion that you can't solve by yourself and at your convenience. Kindly go to the description below this video and find the link to those exercises. We also have WAEC and WAEC past question from 1988 till date for you guys. Even JAMB, we also extracted all the questions JAMB has been asking under motion, and it is right there for you guys. So kindly go at the description below this video and get your own past question. And believe me, those past questions will do you a lot of good. Okay? And if you find these our teachings interesting, you can subscribe to our YouTube channel. You can share with your friends, like our page, and if you have any question that you didn't understand very well, just tell me the question in the comment section and I'll be delighted to help you more. Thank you. I love you.